I want to demonstrate when I bring this can in the electric field. It's a conducting, hollow object. I bring it in an electric field of the Van de Graaff. The thing is a conductor. I will show you that because of the induction, you're going to get, like you see on that figure, you're going to get negative charge on one side, positive charge on the other side, and zero charge on the inside. That's quite amazing, isn't it? If this were positive, let's assume it is, then this side becomes negative, this side becomes positive, the whole thing is in equipotential, no charge inside. Quite amazing. So let's turn on this. The Van de Graaff. So we create that electric field. We turn on the electroscope. Here is my little ping pong ball, conducting, and I'm going to touch first the can on your side, on your left side. There we go. And I bring this charge on the electroscope. Boy, nice charge. I now touch the other side, and I will approach the, I heard a spark. Sparks are always bad. I approach that electroscope, and if the reading of the electroscope, if the deflection becomes less, as we discussed earlier, it means that the polarity that I have on here is different from the polarity on the electroscope. And you clearly see that. The deflection becomes less. So the charge that I took off from this side has a different polarity than the charge that I took on from that side. But yet, it's an equipotential. All that strange polarization of charges takes place at the surface. And now I will try to get inside to see whether I can get some charge from the inside, and there shouldn't be any. Ooh, I have to take this charge off, of course. And I touch this, and you see no charge. So you've seen three things, which is quite amazing. That the charge on this side has a different polarity from the charge on that side, and that everything happens on the surface, nothing happens on the inside. I could not get any charge from the inside.